Welcome everyone. Today I'll be going over linear and cyclic alkanes nomenclature. So this is sort of like a stepwise process instead of having to bombard you with huge amounts of information with lots of different functional groups and lots of different priorities and stuff like that. Just trying to kind of segment everything and compartmentalize, if you will, and try to put everything in order. Okay, so the first thing we're going to go over is main chain identity and prefixes for the carbon count. So, as you guys, I'm sure, have heard of butane, pentane, right? Propane, like propane gas, right? So all those prefixes, those bu, prop, hex, etc., those are all going to be a representative of a particular carbon count. Then there's going to be branching and numbering, so you're going to have to go with the lowest locator numbers, and that way you can kind of make sure that where things are branching off make the most sense. Then some electronegative substituents and their naming, so whether you're talking about particular halides or you're talking about nitro group or some kind of ether, whether it be symmetric or asymmetric. And then some common names, just sort of are trivial names that get thrown out there and are typically used. Then ordering of substituents about a written name. So in other words, how you're going to place them, from left to right when you're actually naming the particular structure. Then we're going to look at some cyclic alkane structures and their derivatives and what branches off of those. And then lastly, we're going to look at asymmetric and symmetric ethers. So let's get started. IUPAC, or the International Union of Pure and Applied Chemistry, is really the sort of a consortium of people that devise these sort of naming rules. Okay, so this is really sort of a sub-branch of naming organic compounds. So they name organometallics and things of that nature, and new molecules that are put together. Okay, so this is really the best convention for going between name and structure. So you may see questions where you're going to have the name, and then kind of working and wearing the shoe on the other foot, so to speak, guessing or trying to systematically devise what the name is based on what you actually see. Okay, so let's just start off with alkanes and main chain identity. So if you're, I have a no name, which is not a no name. Stupid dad joke. Add another 2 there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we don't have anything branching off of here. We have a 9 carbon chain, so it's going to be nonane. Okay, so that ane, that suffix, is just to denote that it's going to be some kind of alkane. Right, and then known is going to give you the instance that there's going to be 9 counts of carbon. Okay, so there's a list of carbon count prefixes on page 54 in table A1 to keep those straight for you. So methyl, or methane, if you have some stuff branching off of a methane group or a methyl group, right? That's just going to be 1 carbon count, right? So it's not going to be very elaborate, but once you get up into octane and no name and decane, it's 8, 9, 10 carbons respectively, where you have to sort of keep track of everything. And of course, we're not just going to be dealing with this kind of chemistry, right? It's gonna be wear kind of smooth after a while and be sort of boring. So now that I've already introduced line structures to you, you know that each one of these points is going to be a particular carbon, right? So had a particular problem for you guys where I was looking for you to have the longest contiguous chain. I was trying to throw you off a little bit. The longest one is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is going to be undecane. So un is an uno, right? Or un if you're speaking French. So un decane, right? So 1 plus 10 is going to give you 11 in total. Sorry about this ugly looking work here. I was trying not to bump into that no name. Okay, so if you were to do a locator number sort of stretch across these 11 carbons that are strung together, you wouldn't start up here in the top right, because if you did, you would end up right here where this branch branch structure is right here, which is 2 carbons long, and this is what is going to be referred to as an ethyl group. So not your Aunt Ethel, but ethane. So in other words, 2 hydrocarbon chains, right? If you shave off that ANE and add YL, that's to be denoted that it's some kind of alkyl branch that's coming off of the main chain, ANE, right? Okay, so this is going to be 1, 2, 3, 4 ethyl undecane. Okay, so there is an example of a branched hydrocarbon. Okay, so let's get into halogens now. Halogens are going to be a pretty common electronegative group that you're going to see for the next few chapters. Guess I could have kept that no name on there, but whatever. I guess I can rewrite it too. Okay, so if we take 1, 2, 3, 4, 5, 6, 7, 8, 9. We take this nitro group and place it right smack dab in the middle. It's going to be at 5. So it really doesn't matter which side we count it from. It's always going to be NO2 at the 5 position. So this is going to be a nitro group. So this would be 5 nitro nonane. Again, 9 for the prefix, or known for the prefix of 9 carbons. Nitro is going to be what this particular functional group is going to be at the 5 position. Okay. Now, here's another. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry about that wacky looking bond there. Okay, so we have 2 chloro groups. So this is a nitro group, this is a chloro group. And then these are bromo groups. So bromo, fluoro, chloro, iodo, those are all halo or halides or halogens that are hanging off of a particular hydrocarbon construct. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9 versus 1, 2, 3, 4, 5, 6, 7, 8, 9, the lowest locator number count that we could do is going from right to left, right? So if we're going the opposite direction, our last one is going to be at 8, whereas this is going to be at 7. So in other words, we could have 2, 3, 7, 7. Okay, so here is where things get interesting. Now you have 2 bromo groups, you have 2 chloro groups, so that's going to be dibromo, dichloro. So in terms of alphabetical order, it should go dibromo, then dichloro, right? So the tiebreaker after the di is going to be B and then C. Okay, so these are the 2 compounds, or sorry, substituents that are going to be hanging off of this main chain, nonane once again. So nonane. Okay. So we're going to have 7, 7. Remember, this is going to be locator number 7. 6, 5, 3, 2, 7, dibromo. And then hyphen for the next series of substituents that are hanging off or branching. So that's going to be 2, 3, dichloro, nonane. And that's it. All right. So just remember that it always defaults to the lowest locator numbers in alphabetical order. Okay, so again, the B and the C here are what it's going to place. So it's going to go A, B, C, D, E, F, G, H, I, J, K, blah, 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 blah. Okay, so when we think about multiple repeats of the same substituent, you're going to have di, tri, so di is going to be for 2, like a diode, right? Or a tri as in a tripod. So if there were, let's say, 3 bromo groups somewhere scattered about this particular molecule that are branching off, you would say tribromo or trichloro, right? So you can also see that little prefix table that I provided for you in the notes. Okay, so what about substituents branched off an alkyl group that's branched? Ooh. Okay, so I have a couple of examples there for you. I've wrote down for hyphen 2-bromoethyl. So now notice that that is going to be in a parentheses. So with that said, that parentheses is going to tell you that this is going to be a branch. Okay, so nonane once again. We have 4 position where things are branched off. So 1, 2, 3, 4. Okay, and then it says 2-bromoethane, or sorry, 2-bromoethyl. Okay. So what that means is that if you're counting off of the junction, and let's say that carbon that's branching off has more than one whatever branch is hanging off of there. In this case, it's going to be ethyl. The numbering scheme is going to go out. So it's going to go 1, 2, 3, 4, 5, 6, 7 if it's, X number long. Okay? So you would put 2, and I put A there just to give you the idea that, it's going to be a subset of counting locator numbers, right? So it's going to be 2-bromoethyl. So how I would write that is 4-2-bromoethyl, all one word, nonane. Okay, so again, to get the lowest locator number, you would go left to right. Okay, so then there's some common or trivial names that the book refers to. So if you wanted a tert-butyl group off of there, I kind of jokingly refer to it as the chicken foot. So everything I draw is just chicken scratch anyway, right? So this is going to be 4 tert for tertiary. Okay, so you have 1, 2, 3 carbons sticking off of that central carbon there, right? So if you think of it just without all this other junk that it's branching off of, that's going to be a tert whatever. It's going to be tert butyl. If you wanted it to be a little bit more formal, you would write, 4 1, 1 dimethyl ethyl. So 2 methyls hanging off of an ethyl in the 1 position. Again, it's not like up here where the branch is off the 2. Alrighty. So with that said, um, that's pretty much branches of branches. Sounds a little meta, doesn't it? Sure is. Okay, so we think of this as a tertiary. How about a sec for secondary butyl? Okay, so that's a count of 4 hanging off of the main chain. Okay, so if that's 4 and it's secondary, so if we ignore everything that's down here on the main chain, this is going to be a secondary carbon, so that means there's going to be 2 carbons connected to this carbon and an additional hydrogen. Okay, so this is going to be 4 sec, as in secondary, sec-butyl 9. Alright. Alright, so pause for a minute and we'll get into some cyclic structures here. Okay, so here are some cyclic alkanes that we're going to go over. Now, some of them are going to have the main chain, and then some of them are going to be branched. Okay, so again, you're just following the convention here. If something is the main chain, then you're just going to write cyclohexane, right? So 1, 2, 3, 4, 5, 6. Okay, and then you're going to have a hexyl group that's branching off of there, so it would be hexyl cyclohexane. Okay, and with that nomenclature, you know, there's no other substituents hanging off anywhere, so there's really it's going to lead to no confusion. Okay. This one's a little bit less straightforward. You have a total of 7 carbon chain hanging off of this cyclopropane. So this would actually be the cyclopropyl group. Okay. And where is it going to be? It's going to be at locator number 2 because you have a 7 count chain here. So it's going to be heptane, hept being 7. Okay, so then you will have 2 cyclopropyl. PYL, again, that YL designation suggests that it's going to be a branching hydrocarbon. Okay, so let's get into ethers as well, because those are kind of easy to knock out. So you're going to see some symmetric ethers, right? So you've heard, I'm sure you guys have heard of diethyl ether, right? So that's going to be diethyl ether. So again, 2 ethyl substituents just hanging off of those oxygens singly bound, or that oxygen singly bound. Okay, so that's going to be a symmetric ether. So that would be ethoxyethane if you were to look at things from a more formal standpoint. But let's say this is asymmetric. Let's say this ethoxy group right here, this OCH2CH3 group is hanging off a much more elaborate structure to the right. Then that would be an ethoxy group. So in other words, it would be, instead of whatever the carbon chain is hanging off of the other side of that oxygen, it's just going to be scratching the YL of whatever that typical branching nomenclature would be, and then you would add OXY for oxygen onto it. So, for instance, again, these are going to be asymmetric ethers. So if we think of this one particular compound, so this is going to be a cycloheptane. So the main chain, and then we have a methyl group hanging off of there. And that is really ugly. Okay, then we have 1, 2, 3, 4, 5. So that is going to be It would be a pentyl group if we didn't have that oxygen and this carbon were directly attached. However, it's going to be a pentoxy. So, it's going to be highest on the sort of count here. So we're going to have 1, 2, 3, 4. So we're going to have 4 methyl, 1 pentoxy cycloheptane. Okay, so why don't you guys, in the end of the notes, give a stab at a few of the examples you want to do, let's say naming, and then ones where you'll actually draw the structures from the name. So pause for a few minutes, and then I'll come back with the answers there for you. Do them systematically. Okay, so to go over some examples here with you. The first one is going to be it's going to have a 1-4 relationship. Okay. So this would be 1, 2, 3, 4, 5, 6. So this is going to be 1 hexyl. Four nitro, cycloheptane. All right. Next up, this one right here, which is going to have not 1 or 2, but 3 bromo groups hanging off the main chain. Okay, so the main chain is going to be 1, 2, 3, 4, 5. I counted it correctly because we're going to go with lowest locator numbers. So it's going to be 2, 3, 4, 5. Okay. So you have a total of 1, 2, 3 bromo groups, so it'll be a tribromo. But it should go 2, 2, 4. So 2, 2, 4 tribromo. Okay, so what is going to be before that is going to be 3 methyl. Okay. Then hyphen 2, 2, 4 hyphen tribromo pentane. Excuse me. Next up is going to be a cycle, and then another couple cycles branching off of that. This funny looking thing here. Okay. Almost looks like a bug. Okay, so we got 2 cyclopropane rings right here. We have a cyclohexane ring in the middle, and we have 2 ethyl groups. So branching off the same carbon, so we can treat this one as number 1, right? And then no matter which way we go, everything's symmetrical. So we'll just say 3, 5. Okay, so it's going to be cyclohexane is the root. And then 3, 5. Di cyclopropyl, and then 1,1-diethyl. Okay, so remember this 2 carbon count chain is going to be an ethyl group. Okay, the next one is going to be an asymmetric ether. So that cyclobutane group is going to take priority over this propyl group. So it should be propoxy, remember, propyl, and then oxy, right, for the oxygen. So it's going to be propoxy cyclobutane, sorry. Okay. So that pretty much wraps it up for the naming of the compounds that I had for you to do. So the things to draw, I will do for you real quick, and then it'll be a wrap. So I'll just erase this top one up here. Okay, so 2,4-dibromo 1-methylheptane. So, sorry, 3-methylheptane. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so 2,4-dibromo. So that means you would have 2,4-dibromo, indicating 2. 3-methyl, which would go right here, and that would check that first one off for you. The second one is going to have cycloheptane is the root, so I'm going to draw this extra ugly looking diamond thing. Okay, so if we have 1,1-dichloro, that means that both are going to be branching off the same carbon. Filling up that octet there. 2-methyl. And then 4-propoxy. Okay, so that means that 3, 4. 1, 2, 3. So prop meaning 3 carbons hang off that other side of that oxygen. So this would be 1,1-dichloro, 2-methyl, 4-propoxy, heptane. Okay, and the last one, 3-sec-butyl, 1,1-difluoro, 4-methyl cyclopentane. So cyclopentane. Let's erase this next one here. So there's a pentagon right there. Let's just put the 2 difluoro groups right there at the top for number 1. Okay. Then we have 3-sec-butyl, so that means 1, 2, 3 is going to hang off of here. Get this out of your way. Doesn't matter what side that ethyl and then methyl group are going to be hanging off of here, because remember there's going to be some free rotation. We'll get into that later. Okay, and then 4-methyl, so that's going to be right here. Okay, so 1, 2, 3, 4. So there's where your methyl is. And that's pretty much it. Alright. Alright guys, have a good one. I'll see you guys when I see you. So this is going to wrap up Module IIB. So I guess it's to be and not to be. I'll see you guys in 2C. All right? Have a good one. Bye.